So hello guys. Yesterday we have discussed about Maxwell's first and second equation. So today we will proceed for the third and fourth one. Okay. So let's see. So Maxwell's third equation is basically based on Faraday's law of electromagnetic induction, which basically states that the EMF generated inside a closed loop is nothing but the negative rate of change of magnetic flux, which in terms of mathematics somehow written like this: closed integral of E dot dl is equal to minus dou by dou t of integration surface integration of B dot dA. Okay, so you can also understand it like because electric field is nothing but electric force per unit charge. So whenever we multiply it with the displacement, that is dl, you will get somehow potential energy, and potential energy per unit charge will give us EMF, or we can say the voltage. Okay, suppose here is a closed loop we have assumed, and in that closed loop, suppose at this particular point electric field is acting like this, so and dl is like this. So E dot dl basically gives us what? The component of E along dl. So the for getting the component of E along dl, we need to resolve it like this. So this is E perpendicular, this is E parallel. So basically now adding it throughout the loop, we'll get how much a charge simply, how much a unit charge is losing energy or gaining energy by completing the loop from this point to this point. Okay, so you can basically understand that. And now one more thing is there that we need to understand for the third equation of Maxwell, that is nothing but Stokes theorem. तो स्टोक्स थ्योरम का मैं आपको थोड़ा सा विजुअलाइजेशन देने का कोशिश करूंगा। तो जो स्टोक्स थ्योरम है वो बेसिकली क्या करता है ना, एक लाइन इंटीग्रल को एक सरफेस इंटीग्रल में कन्वर्ट कर देता है। तो यहाँ पे आप लोग देख सकते हैं कि स्टोक्स थ्योरम का जो स्टेटमेंट है, ई डॉट डी एल इज इक्वल टू इंटीग्रेशन ऑफ ई डॉट डी एल इज इक्वल टू द कॉल ऑफ ई डॉट डी ए इन ए सरफेस इस सरफेस इंटीग्रल। सो हाउ डज इट अराइज? तो अभी हमको देखना है कि ये ट्रू कैसे हुआ और इसको विजुअलाइज कैसे कर सकते हैं। तो देखिए, ई डॉट डी एल का मतलब तो मैं आपको पहले से यहाँ से समझा चुका हूँ कि ई डॉट डी एल का बेसिकली मतलब क्या था। तो अभी हम लोग को देखना है कि जो राइट हैंड साइड है उसका मतलब क्या है। तो राइट हैंड साइड में जो फर्स्ट चीज़ दिया है वो है कि कॉल ऑफ ई। तो किसी भी फील्ड का अगर हम कॉल निकालते हैं किसी भी पॉइंट पर, तो वो बेसिकली हमको क्या देता है कि उस पर्टिकुलर पॉइंट के अराउंड उसका वेक्टर फील्ड कितने अमाउंट का रोटेट कर रहा है। So while rotating, as you know previously, that while rotating, its direction changing every bit of the time. So we need to, for representation of it, we use simply the axial vectors. So for that we need to show it like this. This is nothing but how much it rotates around this a particular point, and this is the axial vector, and this axial vector that we get from the call of that field at that point. So call is nothing but the cross product of E with the del operator that I have already mentioned during the first derivation of first and second equation of Maxwell. तो ये हो गया डेल क्रॉस ई का वैल्यू। तो अभी जब इसको डॉट प्रोडक्ट करेंगे डी ए के साथ, तो डी ए बेसिकली क्या है, एरिया वेक्टर। तो डी ए के साथ डॉट प्रोडक्ट करने के बाद डॉट प्रोडक्ट का जैसे कि मतलब होता है कि वो उसके अलोंग उसका कंपोनेंट निकाल के उसके साथ मल्टीप्लाई कर लेता है। तो यहाँ पे देखिए कि ये जो इस डायरेक्शन में था उसका कंपोनेंट इस तरफ ले लिया, उसका जो पैरेलल कंपोनेंट है उसके साथ डी ए करने के बाद ये एक जो ये छोटा छोटा जो एरिया अज्यूम किए हैं, ये डी ए एरिया के अराउंड वो किस तरह से रोटेट कर रहा है फील्ड, वो हमको देता है। तो अभी देखिए यहाँ पे एक लूप था, अभी हमने यहाँ पे एक लूप से ये लूप को एरिया में कन्वर्ट कर दिया है। तो उसमें से अभी एक छोटा सा एरिया हम लोग अज्यूम किए हैं, और उस छोटे से एरिया को जैसे कि हमने यहाँ पे बताया आपको पहले कि ये जो डेल क्रॉस ई डॉट डी ए का मतलब क्या होता है, उसको हमने आपको बताया। तो उस हिसाब से हम यहाँ पे छोटे छोटे एरिया यहाँ पे ये करते हैं। तो फिर जो इसका जो सरफेस इंटीग्रेशन वो हमको क्या देता है, ये छोटे छोटे एरिया को ऐड करने के बाद जो भी आता है वो उसका सरफेस इंटीग्रेशन है. So here you can see whenever we add some conjugative small areas, some side rotations are getting cancelled. Suppose this one is getting cancelled by this one, like that. So what we are left with, only the surface ones. As in the previous case, in the if you have seen my Gauss divergence theorems derivations, you must be know. So the same thing is happening with this, and only thing we are left with is the surface ones. So now the diagram is somehow similar with this one. So that's how we can say the Stokes theorem is true, as the LHS is equal to RHS. It is nothing like that we can assume this surface only. You can assume any surface in 3 dimension to prove or to state, to understand the Stokes theorem. So here also it is a surface, 3D surface. In the same way you can prove for this one also, but for your understanding I am choosing this basic surface. Okay, so now by using the Stokes theorem we need to do what? By using Stokes theorem we need to modify this Faraday's law statement. So instead of, in place of E dot dl, we are putting this, the call of E dot dA, and so now you can see all are converted into a so the both left hand side and right hand side are converted into a surface integral. So now we can equalize the integrands. So here are the true integrands, del cross E and the dou p by dou t. So that's how the statement or the Maxwell's third equation is been proved. Okay, so now let's proceed for fourth equation. So Maxwell's fourth equation is based on Ampere's Maxwell's law of electromagnetism. It is it is quite similar with the Faraday's law, because Faraday's law is somehow stating about the electrical voltage or electrical EMF, but in this case this one is about magnetic voltage. So here is the statement: the magnetic voltage or the line integral of magnetic field over a closed loop is the result of the current flowing within the curve and the changing electric field inside that curve. Okay, so this is magnetic voltage, and it's in the mathematical form. It is written that the closed line integral of B dot dl is nothing but the magnetic voltage. तो यहाँ पे आप देख सकते हैं कि इसका जो स्टेटमेंट है वो कुछ इस तरह से है. ये है हमारा मैग्नेटिक वोल्टेज, और मैग्नेटिक वोल्टेज कैन बी रिटन इन ऑल्सो इन मैथमेटिकल फॉर्म लाइक दिस: द क्लोज्ड लूप इंटीग्रल ऑफ B dot dl, which is equal to the mu naught I enclosed plus mu naught epsilon naught into dou by dou t of surface integral of E dot dA. Okay, now as you know, I is nothing but the current density in dot dA, or we can say the surface integral of current density. And by using the Stokes theorem, this B dot dl can also be written in this format. So and now all the three terms are converted into a surface integral, that too multiplied with dot dA. So now by equalizing the integrands we will get this statement: this is nothing but Maxwell's fourth equation. So that's all about it. We have proved all the Maxwell's four equations. So thanks for watching.